Okay, let's make a start on the questions. The first one was sine 4x. I'm not going to write d dx each time. So sine 4x. So the rule is derive what's in the brackets. Well, there's no brackets there. There could be. Let's put some blue brackets in. By brackets, I mean what's in front of the sine. So the derivative of 4x is 4. The derivative of sine is cos. And then we rewrite what's in front of the sine initially. So 4 cos 4x. B is the derivative of cos 3x. So we derive what's in those imaginary brackets, which is a 3. We derive cos, which is a minus sine. You can put the minus at the front. And we rewrite the 3x. C, tan 5x. Derive the 5x is 5. Derive tan is sec squared. And rewrite 5x. D. Yuck. I can't write that out. Oh well. D is tan 3x plus 1. Now we have got brackets. And they're not imaginary anymore, but I'm going to put them in blue anyway. Okay. So derive what's in the brackets. 3x plus 1, the derivative of that is 3. If it's anything more than one term, please put it in brackets as well. So it's 3. The derivative of tan is sec squared. And we rewrite what's in the actual brackets now. E, cos of minus x. Well, the derivative of minus x is minus 1. And the derivative of cos is minus sine. So that's going to change that back to a plus. Sine and rewrite the minus x. F, 3 sine x. Now, this is 3 times sine x. So they're two separate entities. Remembering whenever we've got a number in front, it just stays there. So it's 3. We derive the sine, which is cos, and the derivative of x is just 1 anyway, and we write the x down. So if there's a number there, that just stays there. 4 cos 5x minus 3. So that 4 is just going to stay there and get multiplied by the derivative. So the derivative of 5x minus 3 is 5. Multiply that by the 4 is 20. The derivative of cos is minus sine. So I need to put a minus out front there. And 5x minus 3. Next one, 2 cos x cubed. Well, this is the one we were looking at before. The derivative of x cubed is 3x squared. Times that by the 2 is 6x squared. Sine, and it's a minus x cubed. Now, I don't really need a bracket there. They have put one there. If it's only one term, you really don't need one. The next one is 7 tan x squared plus 5. Derivative of the brackets is 2x, multiplied by 7 is 14x. Derivative of tan is sec squared, and rewrite the brackets. Okay, these are becoming a bit mundane now. How about sine 3x plus cos 8x? So your question is, can we add them? Yes, we just do them individually. So we do sine 3x and then we do cos 8x. So the derivative of 3x is 3. The derivative of sine is cos. We rewrite 3x down. The derivative of 8 is 8, and the derivative of cos, you need to think a step ahead. The derivative of cos is minus sine, so that's going to be a minus 8 sine 8x. Of course, you can always change it, but better to do it at the beginning. Now we've got tan pi plus x plus x squared. So we've got a trig function to derive and then just a normal function. Now don't get confused here. What's in the brackets? The derivative of pi, well, pi is not a variable. Pi is just a number. The derivative of any number is 0. So the derivative of what's in the bracket is just a 1. So it's a 1 sec squared pi plus x. And the derivative of x squared is 2x. And I think we can fit one more. X tan x. Now this is actually x times tan x. And so this leads us to the product rule. We've got two variables that are being multiplied and we need to derive them. So the product rule says, might need more space here, write down the first one and get the derivative of the second one, plus write down the second one and get the derivative of the first one, which is just 1. So tidying that up, and without the brackets, that's x sec squared x plus, and we don't need the 1, just the tan x. Alright, so you remember that rule. It's if we had x tan x, and we labelled x as u, tan x as v, then the rule is vu dash plus uv dash. Okay, your old product rule. So up to m. M is sine 2x tan 3x. Okay, let's do this with u's and v's. So that's u and that's v. There's a similar one because in the middle here there's a times. See that blue dot? That's times. So let's write out as we used to. U equals sine 2x. U dash equals 2 cos 2x. And v equals tan 3x. And v dash equals 3 sec squared 3x. Biggest mistake, one of the biggest mistakes people make is, with these trig ones, not differentiating the trig function itself. They do the whole derivative right, they rewrite the 2x at the end, but they forget to derive the trig function. Alright, so our rule is vu dash plus uv dash. So in this case, v is tan 3x, u dash is 2 cos 2x, plus, and then we've got u, which is sine 2x, and v dash is 3 sec squared 3x. Okay, we're going to try and put all these together. Remember that the 3x can't be separated from the tan. They're Siamese twins. They're together for life. So don't ever divide or times or, that doesn't become a 4x there. That's a separate entity. BIMDAS, sort of, if we had another BIMDAS, it could be a T for trig functions and log functions and exponential functions because they can't be split up. So let's simplify this. The numbers go at the front. So we've got 2 tan 3x cos 2x plus, and we've got 3 sine 2x sec squared 3x. And if you can take a common factor out, do, but we can't in this case, so that's the end of that one. It's a longer one. Okay, and this is now a quotient rule one, where the numerator is u and the denominator is v. You remember the quotient rule, it's vu dash minus uv dash all over v squared. So let's write down that u equals sine x, u dash equals cos x, v equals 2x, and v dash equals 2. And we'll plug it in. We've changed to blue. So we've got 2x, which is v, times u dash, which is cos x, minus sine x is u, and v dash is 2, all over v squared, which is 2x all squared, and keep your brackets. Put them all in brackets, and then the next line simplify. Don't try and do all in one hit. So the first one reads correctly. We've got the 2 which goes first, then we've got any variables, and then we've got the trig function. If you write it the other way, it's okay, but this is convention. So the 2 comes first, and then sine x, all over, and we might square that out. We say not to square out the brackets if there's more than one term. But if it's only one term, that is a 4x squared. That's quite okay to do that. And we have 2 as a common factor. So let's take out the 2 at the top as a common factor. We've got x cos x left minus sine x. And I took it out because I noticed I could cancel it on the bottom. 2 goes into 4 twice. So what I've got is x cos x minus sine x all over 2x squared. You should always be trying to simplify it. I'll just change that. Because sometimes that helps solve further along in the question. Now you guys can do, excuse me, O by yourselves. That's another quotient rule. But this one here, who remembers what this looks like when you've got an indice? What rule do we need to use? That's right, it's the chain rule. Well done to everybody that said that. So the chain rule said, take the indice to the front, rewrite the brackets. It's the function of a function rule that we were just using actually to derive the trig. Minus 1 from the index, and then multiply by the derivative, and we need brackets because there's 2 terms. So the derivative of 2x is 2, and the derivative of tan 7x is 7, sec squared 7x. And I would just leave that like that. There's no point in multiplying the 9 in. Just leave that one. And the last one, q, is sine squared x. Now, that is not the same as sine x squared. Sine x squared could be written like that. So the x squared is the function, and the square only applies to the x. Whereas in this one here, if the square is in the middle, that is the same thing as saying that does equal sine x all squared. And you can see there's a difference. So the sine x, you work that out and you square the whole thing, whereas sine x squared, you're only squaring the x. So if it's written like that, the square only applies to the x. If they want you to apply it to the whole thing, then they'll put it in brackets like that, but more regularly, the 2 just goes in the middle there, or cubed, or whatever indice it is. So having said that, this is another chain rule one. So the 2 goes to the front, sine x is rewritten, we reduce that by 1, just put a 1 there, and the derivative of cos x is sine x. So I can really write that without the brackets and without the indice. Just write 2 sine x cos x. All right, hope you've enjoyed that lesson. Very long one. Goodbye.